program on time. So fortunately, we have about 3 minutes left for the next piece, which is the panel. Actually, we have more than 3 minutes, fortunately. So I'm pleased to introduce my co-organizer of Texas Wireless Summit, Professor Jeff Andrews. Jeff is a longtime friend, collaborator. We've known each other since before coming to UT, and many of you may know Jeff for his work in, maybe his early work in interference cancellation in CDMA, or the more recent work in analysis of cellular communication systems with voice-on-point processes, or heterogeneous networks, or the millimeter wave work now. He's received a whole bunch of awards. In fact, half of his wall is covered with awards. It's good because it's the wall we share, and it tends to attenuate the acoustics. So with that, Jeff, come on up here and introduce your panel.
Okay, I'd like to invite our four panelists to come down. You can just go ahead and take a seat, get comfy, maybe spread down a little bit closer to me so I can more hit you easily if your answers drone on. Okay, great. Okay. So I've been actually really excited about this panel. I've got kind of my dream team panel here that I think should hopefully be provocative. And we've been talking for a while about what we want to cover in this panel. So I'm going to keep my introductory remarks quite brief, and then I'll let each panelist give some introductory remarks. I'll ask some questions, and then we'll open it up to the audience for questions. Okay. And so this panel, again, we're in the morning here, so this is still kind of about the why we need 5G. And so this is the fact that there's just not going to be a spectrum available the way we've had in the past. There's not big new blocks that are going to be auctioned off for exclusive licenses. So we're going to need to come up with new spectrum paradigms. So first, I want to talk about the role of unlicensed spectrum in 5G, and then we'll talk about more general paradigms. Okay, so. As I was just saying, there's just really not that much spectrum left. The scarcity, is made obvious just when you look at the most recent auction. I think this was last year, the AWS 3 auction, as it's called, and it's prime beachfront spectrum, centered around 2 gigahertz. About 65 megahertz of spectrum went for about $45 billion. And if you kind of do the math here, that's about $700 for a single hertz for nationwide coverage. I mean, this is a kind of a back of the envelope calculation. Because these licenses are auctioned off regionally. It's really quite a complex process. But in the meanwhile, if you look up at the 5 gigahertz band, there's about half a gigahertz or more there that's unlicensed. And at least at the present time, it's fairly lightly used nationally. And much of this spectrum is actually available in an unlicensed fashion internationally. So if you take that valuation, which I understand, 5 gigahertz is perhaps a little harder to use than these frequencies. Furthermore, there's additional requirements, for example, transmit power levels. But let's just say it's worth the same. And if it's not now, it will be in a few years because this is a rapidly escalating asset. It's about $400 billion worth of spectrum just sitting there. So it's no wonder that the cellular industry is interested in using this spectrum. And it's mostly used right now for Wi-Fi and other types of instrumentation. And it's unlicensed. Just because Wi-Fi is the primary incumbent doesn't mean that they have rights to it. It is a public asset, and it's available for different technologies. Okay, so the big development we've been hearing about, and I think it's a lot of what our panel will discuss today, is the LTE move into unlicensed spectrum. Okay, so this has various different names. LTE-U for LTE unlicensed. There's a effort right now underway in the main standard body, 3GPP, called license assisted access. Which is different in the sense that it tries to use the licenses that the cellular operators have to control then access into the unlicensed spectrum. And you'll hear a lot more about this from the panel. We'll get to them. But I think in addition to this, which could be considered not really properly 5G, this may be 4.5G. It raises a lot of very interesting questions for 5G and beyond. And there's coexistence issues with Wi-Fi. Wi-Fi is incredibly successful technology, as we know. Will this become a new paradigm for operation of spectrum in 5G? If we can figure this out successfully here for 4.5G, then this would be a good way to use other subprime or shared spectrum. Examples being millimeter wave, which we know Farouk made some good points about myths of millimeter wave this morning, but the fact is the millimeter waves just don't go through stuff very well. So, your cell phone's not going to work in here with using millimeter wave without a repeater somewhere from the outdoor to the indoor. Okay, so how can we, for example, build a joint system that's both licensed and then subprime spectrum like millimeter wave or this 3.5 gigahertz band, which you have to shut off with 60 seconds notice. If an aircraft carrier comes nearby. All right, this is a new thing that's coming down the pike. So there's going to be all these different ways we kind of cobble together spectrum. Again, like Brian Modoff spoke about this morning, and it seems like this is kind of the first effort by the cellular industry to really do this in a cohesive way. Okay, so I think it has big implications for FCC action in the future as well. Okay, so that's my opening spiel. Now let's get to the real experts on the topic here. And so I'll start, so I'll introduce them, and then I'll let them each make some intro remarks. I've told them about 5 to 8 minutes each. So the first is Eduardo Esteves. He's a VP at Qualcomm, and he's very generously agreed, as of yesterday, to be on this panel. We were going to have his colleague at Qualcomm Research, Mingxi Fan, but he came down with a bad fever and was unable to travel. But luckily, Eduardo is here and has worked with him from the early days on LTE unlicensed. And so he has a great deal of experience in cellular communications. He's worked on all kinds of things in both cellular standards as well as in genomic and computer vision. And he likes to watch and talk about soccer, and I'm assuming he likes that person who plays for Real Madrid. And being a Barcelona fan, maybe we can just move on to your technical comments. So I'll hand it over to you, Eduardo, and I'll just give you the controls there.
Thank you, Jeff. It's a pleasure to be here. Like Jeff mentioned, I'm replacing my colleague who is Mingxi Fan, who is sick. But nevertheless, so I'm going to be using some of his slides that he prepared for the panel as an introduction. So essentially, when we look at the problem of licensed and unlicensed spectrum and the best way to utilize it, we can think about what's happening in the cellular industry with LTE, LTE Advanced, and now we're beginning to talk about 5G. So on the left side, you see the traditional cellular license spectrum utilization. And then on the right side, we see the evolution on Wi-Fi with AC, AX, we have AD for 60 gigahertz, and we'll continue to evolve. And so in the middle, so basically we said, all right, so what was happening was that devices like this one or others, your devices, already had licensed and non-licensed spectrum capabilities built in. And the wireless carriers were trying to manage that, trying to get the best user experience provided to the customers. And in fact, some of them came to us years ago and he basically said, the experience to transition from cellular to Wi-Fi and vice versa, it's not clean. There was authentication issues, RF issues, there's a tendency to device once it moves to Wi-Fi, get stuck in Wi-Fi and not come back to cellular even though the Wi-Fi signal is long gone. Can you solve this problem? And we started working on solutions for, in fact, enabling a better user experience, aggregating and combining Wi-Fi and unlicensed spectrum and cellular with LTE. But then as we worked those solutions, and we have worked on those solutions, and I'll talk a little bit about that, we realized that what we actually needed was already available. And it was available in LTE. Everything we needed. So then we just came up with this idea of using a licensed spectrum and LTE non-licensed in different flavors like Jeff mentioned to basically provide the optimal user experience by combining the unlicensed spectrum and the licensed spectrum in the same device. So just as an illustration, what I just described, so the top description there, which is we're talking about link aggregation. This is an an evolution of that path to combine, basically provide the best use of a combination of Wi-Fi and a cellular system like LTE. And there were many mechanisms to do that. There's mechanisms that are being done, so we could do that at the IP layer, TCP layer, or the PDCP layer, which is one of the layers inside the LTE stack. And that provides much better performance in terms of switching between LTE cellular and Wi-Fi. But you can actually do better. You can do even better by bringing that kind of a synergy even down lower in the stack. And the best way, the more natural way to do it is to actually leverage the same, or try to leverage as much as you can, the PHY and the MAC stack that is already present in LTE. And that's the lower part of the diagram, where we basically rely on the mechanisms from carrier aggregation, LTE carrier aggregation, that are already in the spec for LTE. And then simply you could see the unlicensed spectrum as just another carrier from that perspective, and leverage the framework for adding and removing carriers, mobility management, interference management, and all those things, they're already in place in the LTE spec. So essentially, there are like three flavors that we can achieve that. LTE, what's called LTU, or LTE non-licensed, the first flavor is a flavor that actually is focused on downlink only. So it's only the small cell transmitting to a device, no uplink in the unlicensed frequency band. And because of that, it was simple to just leverage existing standardization up to release 12. So actually compatible with release 10, 11, and 12. So no change needed to the interface. And that is a solution that is applicable depending on the unlicensed spectrum regulatory requirements in each region. It's essentially could be applicable in many regions, in particular here in the US and other markets like Korea and India. The second flavor is what's called LAA, or Licensed Assisted Access. And that is what is being discussed and standardized into GPP as part of Release 13. So initially the idea there was to make air interface changes and also support downlink and uplink. But for various reasons, the initial work in Release 13, various non-technical reasons, by the way, the initial work in Release 13 has been focused also on downlink. And there introduce a new additional mechanisms that would meet additional requirements from certain markets like Europe and Japan. And then we've been talking about a third version, which is called the multifier, which is a version that essentially is an uplink and downlink completely independent of the licensed spectrum and using just the unlicensed spectrum. So that would be an interesting opportunity for non-cellular operators to actually leverage the benefits of the LTE technology. So I'm just going to show quickly a couple slides here that shows coexistence. That's a big issue. So when we start working on this, and one of the first things we wanted to do is make sure that design would coexist very well with other technologies, in particular Wi-Fi. So here we're just showing you one snapshot of a test, an extensive set of tests we did in the lab. We have an RF chamber, so we control the RF environment really carefully there. We have a lot of access points, and starting from the left, we have the baseline scenario where all the access points have 8 access points and 8 stations being served in that small area shown in the picture. And that kind of is a trace there shows the throughput performance of the various, the different 8 access point and stations there. The pink curve shows the average of all the scenarios there, all the access point, the stations. And as we move to the left, so what we did is we replaced the device in the center there. We replaced one with LTU, and then we measure the Wi-Fi, the remaining Wi-Fi performance, and that's the trace you see. You see a little bit of increase on the pink curve, which shows the Wi-Fi average performance actually starts improving. And as you change, start replacing more of the Wi-Fi access points with LTU, small cells, you keep seeing that trend. So up to the point where we have half and half, 4 Wi-Fi access points and 4 LTU access points. So basically that is showing that not only LTU coexists well with Wi-Fi, but actually helps improve the Wi-Fi performance in a very dense scenario like this one. And I think I'm going to get out of time. We can talk more about it later.
Great. So thanks, Eduardo. So that's, I guess, Qualcomm's take is that actually LTE improves Wi-Fi performance. So let's move to Google's point of view now. So I invited Nihar here. Nihar moved to Google about a year ago from Broadcom, where he worked on Wi-Fi for a few years. And Nihar is a very unusual case of a superstar in academia moving to industry. He'd won, our students learn his contributions to, for example, MIMO and the broadcast channel. He solved longstanding opening problems. That won, very prestigious Best Paper Awards, and was really one of the stars of his generation. And just got tired of the cold weather and of, teaching and these kind of things. And decided to go into industries a few years ago. So it's great now we can come back and share his perspective in industry as well. So Nihar, why don't you come up and give some opening remarks?
Thanks, Jeff. Great to be here. My comments are quite brief. So unlicensed spectrum, of course, at Google we find great value in unlicensed spectrum. I think there's no disagreement on kind of the points being made here that we've seen tremendous innovation in the past 2 decades since the FCC opened up the unlicensed band with the 2.4 gigahertz and many more bands that have followed. Wi-Fi and Bluetooth are, of course, the most prominent examples, but they're not the only users of the unlicensed bands today. Cisco has, there are many known statistics, well-known statistics about how much traffic is carried on over the unlicensed spectrum. Cisco's most recent report said something about like 50% of mobile data traffic is carried on unlicensed spectrum. That percentage is even slightly increasing. I think if you include not just mobile data, but data overall, including laptops and so forth, it's even higher if you think about the fact that laptops, tablets, for example, many of them are Wi-Fi only, don't have cellular connectivity. The scope of unlicensed spectrum is expanding, and actually pretty rapidly. 2.4 has been extremely successful, about 80 megahertz of spectrum there. As Jeff mentioned earlier, at the 5 gigahertz band, there's hundreds of megahertz of spectrum, and that has been increasing. The power limits have been loosened by the FCC over the past few years, and you're seeing more and more devices supporting 5 gigahertz today, and more traffic being carried on the 5 gigahertz band. But of course, those aren't the only places where unlicensed is popular. There are bands under 1 gigahertz. There's lots of development with TV white space. The FCC is going forward with auctions in 2016 that will auctioning off some licensed spectrum and then also opening up some additional spectrum for use by unlicensed devices. 900 megahertz already has about 26 megahertz of unlicensed spectrum. 802.11aH, for example, is defined to operate in that band. That's not a worldwide band, but there is spectrum around the 900 megahertz range with better propagation characteristics. 3.5 gigahertz is a particularly interesting case, and I have a slide talking about the sharing model there that was very recently opened up by the FCC with a new sharing mechanism. It's 150 megahertz of spectrum, so Google sees lots of promise there. And of course, 60 gigahertz is where we have about 7 gigahertz of unlicensed spectrum at millimeter wave. 802.11ad looks like we'll be hitting the markets very soon. I know Qualcomm's made recent announcements about chips supporting that standard. That could bring, gigabit kind of, or more than gigabit data rate at a short range. And of course, along with unlicensed spectrum, Google, we do, of course, believe a balanced approach to spectrum is needed. It's not like unlicensed is the only thing that's needed. Of course, we need a balance of licensed and unlicensed, and we're supportive of both. So on to 3.5 gigahertz, which really presents a new model for spectrum sharing. So I'm not quite sure how familiar people are with this, but the FCC came out with the ruling a couple of months ago. So what the FCC adopted was a 3-tier spectrum sharing model. This actually started out with a PCAST report. This is the Presidential Council Council on Science and Technology, I believe, and the report came out in about 2012. The FCC adopted this model or something based on that report in 2015 for 3.5 gigahertz to 3.7 gigahertz. So this band is primarily used by radars, by some satellite operations, by some terrestrial internet access techniques also. So the novelty here is that it's a three-tier spectrum sharing model. So that we, instead of kind of the, two-tier spectrum sharing is already done today. For example, on 5 gigahertz in the DFS bands, where there are airport radars, for example, operating that are the incumbents, and unlicensed users can use that spectrum when the radars are not in operation. The novelty in the 3.5 band is a third tier to kind of increase some certainty for the non-incumbent users. So the tier 1 users are the traditional incumbents, for example, radar, and all lower tier users defer to tier 1. And then the new concept here is to have tier 2, which is referred to as PAL, for primary access licensee. And these users also defer to tier 1, to the incumbents, but they otherwise have exclusive rights to spectrum, which they actually purchase through auctions. So the specifics here are that you can purchase 10 megahertz chunks of the spectrum per geographic area. Geographic area here is the census tract. The license that is purchased is for 3 years, and a licensee may aggregate up to 40 megahertz in one area. Okay, so then, of course, the idea is that a tier two user purchases the spectrum. If tier 1 is there, they have to defer, of course, but as long as tier 1 is not present at the time, which is in many cases, the tier 1 users are not expected to be present very often at all, the tier two users have exclusive right to the spectrum. And then there's one additional tier, which is kind of you can think of it as the traditional kind of unlicensed model, which is tier 3, referred to as GAA, or General Authorized Access. This is completely free. These users can use the spectrum anytime tier 1 or tier 2 is not there. Okay? And another key point here is that there's a spectrum access system, or a SAS, which actually is kind of a database-like entity which devices need to basically get permission to operate initially and ongoing for both tier 2 or tier 3 use. And tier 2 use doesn't cover the entire band. Only up to 70 megahertz of the 150 megahertz in the band can be used for tier 2, which means that at least 80 megahertz of this band is open for GAA use whenever tier 1 devices are not there. So we think there's a lot of promise in this kind of model. We're looking forward to seeing how the market adopts this band. Okay, and last slide, actually, finally on to coexistence. Qualcomm touched on some of these points with regards to the 5 gigahertz band. Of course, again, there's not going to be any disagreement on this point. For unlicensed spectrum, it's been extremely valuable, and for it to continue to thrive, coexistence between technologies is, of course, critical. Industry has typically been able to work out these issues via standards bodies, and what we hope is that this can continue. I think a great example is Wi-Fi and Bluetooth in the 2.4 band. If you looked at those technologies, they really were not compatible 10, 15 years ago. Both technologies made changes to limit themselves so that they were able to work together. I mean, they are fundamentally quite different systems, but they have managed to work and reasonably well in 2.4 gigahertz. We think LAA in the 3GPP version of LTE and license is potentially another example where the parties can come together and come up with a technical solution that works for both technologies. One unique wrinkle we think in LTE in unlicensed operation is that it's a license anchor system. So this is something that we think is new in the unlicensed bands. So a license anchor system is a system that operates in both licensed and in unlicensed spectrum at the same time, and it can move basically seamlessly between the bands. And what this really changes to the coexistence picture is that if you're license anchored, you always have a fallback in the licensed band. And so this can change the incentive to coexist in the unlicensed band. It's quite different when you think about coexistence for the perspective of a technology like Wi-Fi, where the unlicensed band is the only place it can play, whereas if compared to a technology that has a backstop. So we're not trying to, the point to be made here is that this just really increases the need for a well-functioning coexistence. This is not to say that it won't work. Okay? And we do think, last comment is that we do think that spectrum access systems such as in 3.5 could potentially serve an important role in coexistence, not just in the 3.5 band, but more generally.
Okay, thanks, Nihar. Should note also, Nihar was one of the two authors of Google's recent white paper that got a lot of people have read on the coexistence issue. So he's been working on this issue specifically at Google. So our next panelist is Vinko Erceg. Vinko is one of Broadcom's really top technical people on Wi-Fi. He's made seminal contributions to the Wi-Fi standards over the years, both in a leadership role and in a technical role. He's well known for the Erceg channel model that he developed a long time ago. Other people gave it that name, not him. He's done really fundamental work on both 11N and 11AC as far as the MIMO characteristics. He also has a distinguished record of patenting and intellectual property, and now he's particularly working on Wi-Fi LTE coexistence. So he's just the perfect guy to have here from Broadcom. And just a fun fact about him is he was that guy driving you really fast, and you wish you had an automated car in from the JFK while he was doing his PhD. All right, Vinko, please.
Oh, thank you, Jeff. I'm very happy to be here, delighted. So which way is, it's green one, huh? Going forward.
I think it's actually the right one.
The right one, okay, got it. Thank you. So this talk is going to be about LTE and LAA and Wi-Fi. So I give it from the perspective of a company that has a large interest, big interest in Wi-Fi. But also I'm not saying that we don't have interest in LTU or LAA, because we did show a demo recently that had the LTU and Wi-Fi on the same platform. So we would like to really work on a very good coexistence between these systems, and this is really our imperative and the first thing that comes to our mind, because we have billions of Wi-Fi devices deployed. I have a graph actually on that, deployed worldwide. So we already had from Eduardo and Jeff and Nihar already mentioned this. So what we have now here in LTU and LAA, we have an anchor in the and a license spectrum, that's a license channel. When we have the additional channels, could be 20, 40, 80, 100. There are people even talking about 160 megahertz in 5 gigahertz on the unlicensed channels. So it could be multiple of the channels. But we're starting with 20 and discussions around 20, simulations around 20 in 3GPP and also elsewhere, but it can definitely move on the wider frequencies. It can move to the different bands. So probably we'll have discussion on the panel regarding that going to 600 megahertz, 900 megahertz, 3.5, 3.1 to 3.5, 2.4 maybe 5 gigahertz or 60 gigahertz, which we have millimeter waves. So could be any band, licensed and unlicensed carriers. The first, what we in release 13 now in the 3GPP, it's related to the downlink only. It's called supplemental downlink. And pretty soon in the release 14 or even some release 13 will be on the uplink also. So we have two flavors, as was described very clearly. We have LTU, which is proprietary mode. It was done by a few companies in the LTU form. So it was developed last year and this year. So not everybody has access to this, and it's closed, and we really don't have too much influence, the other companies, into this, which is unfortunate, and I'll talk about that a little bit later. And the other one is LAA, which is a version being debated and discussed and specified in 3GPP. So this is open forum. Personally, I'm much more happier with this kind of interaction when we can show the results and do the simulations and debate with the companies on the floor, what should be done or what should not be done for the good coexistence. And it's primarily restricted to small cell usage cases. So LTU and LAA are small cells. So it's not going to be widespread, that's my opinion. Small cells, how many of us have a small cell in their house? Probably none, maybe one who's experimenting with it. There you go, Ted has. Anybody else has a small cell here? Please raise your hand. So Ted is the only one that has. Congratulations. It'll be hotspot, so I think it will remain like that. So it will be hotspot, and maybe some coverages in the neighborhoods where the small cells are, hotels. Starbucks. So Wi-Fi will be there and will remain to be there. And multifier that was mentioned by Eduardo, there's something new. We'll really see what that's going to do in the market and how popular it's going to become. What is Wi-Fi now? Look how much do we have, how many devices. This is the, we have cumulative shipments are 9.98 billion by December 2014. 10 billion devices. It's not million or 10 million, it's billion. 10 billion devices, and we have 4.5 billion as of today. So these are in operation devices, which we have operational. So it's a huge, huge installed base of these devices, and it's really important to have a good coexistence. We cannot stomp over these devices, and just needs to be good, well designed. So what is the Wi-Fi? Wi-Fi started with .11n. We had 450 megabits per second with few antennas, and then 11AC, 1.75 gigabits per second with 4 antennas and 80 megahertz. Now we're at 3.5 gigabits per second if your company or somebody's company implements 160 megahertz bandwidth and 4 antennas, which is now becoming actually common. So I believe in 2016, 2017, we will have 4 antennas and 160 megahertz bandwidth. Some companies are already having some press releases with 8 antennas. So, but how how good that is, how MIMO operates with those number of antennas and spatial streams, that's to be debated. We're working on 11AX right now. This is looking like LTE, very close to LTE 11AX. So these two technologies are becoming or looking similar, very similar to each other. We have OFDMA uplink downlink now in 11AX. We have multi-user MIMO uplink and downlink. Modulation will go to 10,000 QAM, probably 10 to 24. This is being debated and proposed. So it's very advanced technology. So it's really imperative by using these 160 megahertz bandwidths that we do need a great coexistence mechanism, just not some ad hoc things that to throw away very quickly to put it in the market. Next slide. Okay, so this is a lot of wording here. Maybe I should have reduced the number of words, but let me just summarize it, what it is. So Broadcom, Google, a few other companies in 3GPP, we are pushing coexistence mechanism, which is similar to Wi-Fi, because we have these 5 billion devices, 4.5 billion devices present, then we would need to use, to get a good coexistence mechanism, something similar that Wi-Fi is doing. So there are 3 elements for good coexistence that would be with Wi-Fi, at least that's what I believe. Nihar, do you? Or also, so few of us at least, a lot of other companies. It's the initial defer time, so that's around 43 microseconds that we have in Wi-Fi. So basically, before you transmit, you wait for 43 microseconds for the other transmissions to just finish, that they have enough time to finish their transmission. You don't jump over them. So that's number 1, initial defer time. The second one is exponential backoff or some kind of increasing backoff. So if there is a collision on the air, then you double your waiting period next time, and there is a collision again, then 4 times, and then 8 times. So that exponentially grows. It's a curve that's up, skyrocketing pretty quickly. So we do have that in the Wi-Fi. And the third one is low detection threshold. This is the most debated parameter and which people don't agree. And actually, depending on this parameter, the coexistence will be good or bad. And maybe we can have a debate on this. In 3GPP, the things were looking good first, but now this week they don't look good anymore because people are pushing minus 62 dBm of coexistence, for coexistence threshold. That's very high. Wi-Fi operates up to minus 95 dBm in easy channels, AWGN, let's say, but minus 90. So there's a 30 dB of discrepancy that we are talking. Results are not good if you minus 62 dBm because you don't see 80% of the Wi-Fi devices. You don't acknowledge them at all. You stomp over them, you transmit, or so. It's not good. And throughput is and delay is being. It's not good. It's suffering quite a bit. I can show some. Okay, here is the slide. Jeff, how many minutes?
Yeah, 1 minute.
1 more minute. Okay, so this is the slide of the latency versus different mechanisms, coexistence mechanisms implemented. And this is for 4 Wi-Fi networks and 4 LAA nodes with 10 UEs or stays, which means the mobile units, which are not nodes. So 10 per each. And we have 2 Wi-Fi voice RIP users in the network A and the same in the network B. So if we have on the result on the left side is using the Wi-Fi to Wi-Fi network. So network A is Wi-Fi, network B is Wi-Fi. So that's with all the coexistence mechanism. And the other ones are if you include different of those 3 mechanisms that I used, that I noted before. So if you use only defer time, that's the third one. The third one, so the delay is around 600 milliseconds, which is terrible. You cannot operate with 600 megahertz delay. The second one is EU regulations. And then the fourth one is with initial weight and exponential backoff. And then a fourth one is with initial weight and a carrier sense at a low level. And the last one is when you have all three for the robust coexistence. So it's network A, network B, which is LAA or LAA, and network A is Wi-Fi. And then it's the same performance and when you have two Wi-Fi networks. Okay, that's it. So I have two more slides, but we can discuss those later. Thank you.
Thanks, Vinko. Cool. So yeah, we want to make sure we get to the Q&A, which I think we'll ferret this out. So I think some interesting points there, that the latency really does ramp. If LTE doesn't behave like Wi-Fi, which kind of defeats the point, then it brings down Wi-Fi, according to these results. Okay, so I thought last we'd hear from a carrier. So I invited Arun Ghosh, who's here at AT&T Labs in Austin, and he's director of the Advanced Wireless Technology Group there at AT&T Labs. You know, he's worked extensively on many different technologies for 3G, 4G. You know, we've co-authored books on WiMAX and LTE together with Arun, so I know Arun very well. And he's particularly interested in this coexistence issue. So he's also extremely handsome fellow and answers to the name Dr. Bollywood. So we'll invite Arun up to make some comments.
Thanks, Jeff, for that rather unusual but interesting introduction. Pleasure to be here, and thanks for the opportunity. So I thought, I'm going to take a little bit of a technology agnostic view because, as an operator, all technologies are really of interest, and we like to apply them, where they're the right tool. So as long as the technology is coming out of a standards organization and we can ensure interoperability between access points and devices, it's a technology of interest to us. So I'm going to take a little bit more of a theoretical and perhaps more of a philosophical view about unlicensed band and why some of the industry impetus is in that direction, and what we envision will happen in the case of as we go even forward towards 5G and millimeter wave, and can some of these concepts and these unlicensed technologies, how can they operate? So, unlicensed technologies and usage of unlicensed and licensed together is not something that is unusual to us. We have been doing this for a while. Way back, if you remember, in 2G systems, there really wasn't a coexistence. The coexistence point was you. I mean, you were the person when you had one kind of services on cellular technology, which were voices and perhaps SMS, and you had another kind of service that you depended on Wi-Fi to provide, which was high bandwidth, and you would switch. I mean, you were the coexistence point. But with cellular industry itself coming to a point where we could start providing high bandwidth applications, many of these high bandwidth applications became part of your mobile device. So you have an iPhone or you have a Samsung phone, and it can do all the applications that you want. So you want the same usage to be delivered to you using the licensed band and the unlicensed band in the same device, and the device became the coexistence point at that point. And that's really where the majority of the deployment today is. You switch between LTE and Wi-Fi, and in fact, we are able to keep something like a voice carrier still on the LTE while you're still on the Wi-Fi. So it's not either or. There is a certain degree of bifurcation of traffic and intelligent routing of traffic between the two. But I think as an operator, we see that is not the most efficient way of using unlicensed resources. And why are we interested in unlicensed resources? And I think based on trends and based on what you see today is that licensed spectrum has started to become more and more congested. They are running at higher utilization. They are expensive. And as an operator or anybody, if there are unlicensed resources, I think it's absolutely of interest, and which is what this trend kind of shows. But the reason, but the gist, when we look forward, the way it is evolving is that we want to keep the ability to move traffic around in the network rather than keeping it in the device, which is where this whole effort towards LAA, LTU, or LWA, which is actually the integration of Wi-Fi and LTE using dual connectivity, is towards. You have some kind of an intelligent scheduler or traffic shaping algorithm that resides at your PDCP layer, and that does the routing of the traffic, towards whichever radio access technology, towards whichever unlicensed or licensed band that you seem favorable. And that is actually a very, fertile area of investigation. Today we have very static algorithms, as we investigate dual connectivity, we have very static, flow control algorithms between the two. I think that is a very rich area where we can utilize things like machine learning and data sciences to reshape the policy of how you move your traffic around between the different technologies, between different licensed and unlicensed carrier as things change. So how you utilize licensed versus unlicensed during busy hour in Manhattan can be very different than what you do in your home in suburban Austin in the middle of the night. And they could be completely different policies, and it's very difficult to come up with one solution that works best everywhere. And really, which is where I think, at least from our company's point of view, there is a very fertile area in the field of machine learning and data sciences that we think, we will look forward to optimize a lot of this, traffic shaping. So that's very well and done for the licensed and unlicensed band, but where are we going with this in 5G? And I think I agree, with some of the comments that Nihar made, is that the best option is really having a licensed anchor. And one of the reasons for that is because there are certain kind of traffics that you cannot move to unlicensed carriers, things that are mission critical, things that require high quality of service, high reliability. So as a carrier, I would always prefer to have a certain amount of licensed carrier where I can put these quality of service and mission critical and, like vehicle to vehicle or, collision avoidance. Those need their own set of, license, carrier where you can guarantee the availability of the service. But I think millimeter wave poses interesting challenges as well as an opportunity. So I'm going to talk about the opportunity first, which is actually at the bottom. Things are getting more dense. Gone are the days where everything goes through macro cells. Things are becoming smaller. Channel bandwidths are getting wider. I mean, we're already talking about gigahertz of bandwidth in millimeter wave. Densification is happening. So as a result, the behavior of the traffic is really very stochastic, and it changes dynamically over time. Which means that if you have a certain amount of spectrum, it is possible that multiple entities can start sharing some of that spectrum, which is why, the concept of unlicensed band, really depends on that. It depends on the, stochastic non-correlated, traffic patterns across, different networks, even on smaller timescales. And that is happening as your bandwidth becomes larger, as your the footprint becomes smaller, that becomes a dominant factor. So, the ability to use 60 gigahertz, for example, will be a very interesting, option, along with, more licensed carriers like the 28 gigahertz. But there are some interesting challenges as well. How do you do listen before talk in a system which is where the coupling is extremely dynamic and very directional through the usage of these, directional phased array beams in millimeter wave? It is not something that is, really that simple. But you can think that listen before talk mechanisms can evolve to something instead of a general decision. It could be a very direction specific decision, which further increases the spatial reuse of unlicensed spectrum. And I think once you bring in concepts of massive MIMO and FD MIMO in the unlicensed band, you can actually improve the utilization of the system itself. So it becomes a fruitful ground to utilize. And I think that's really, what the basis of my talk is, that it's unlicensed band is a very useful, opportunistic, resource that we would definitely like to use. But I think in many ways, having a licensed carrier, a conjunction of licensed carrier and unlicensed carrier, which is really where the most of the industry seems to be moving, is really the right direction to go. Thank you.
Thanks, Arun. Oops. So can we just fade back? I'm talking to the AV people to just the title slide. Okay, so we have about a half hour left for the panel here, and I want to make sure that the audience gets some chances to ask questions. So I'll start with a question that every single person in the audience probably cares about since they have a smartphone, which is, how, if just from the user's perspective, and this might be a question for you, Arun, or possibly for Eduardo, how will they know when they're on LTE unlicensed, or will they know? Right now, on your phone, you can see whether you're connected to Wi-Fi or LTE, and although it's gotten a lot better, at least for me, the performance is often pretty lousy when you hand over to Wi-Fi. It doesn't know when to hand back to LTE, so you want to be having some experience where it thinks it's kind of still connected to Wi-Fi, it's not, stuff doesn't work, then you have to turn off the Wi-Fi connection, go back to LTE. Everyone's had this experience probably that has a smartphone. So how will this work for unlicensed LTE? Will you know that you're on it? Will the operator still charge you bit for bit, the same that they charge you, on the licensed spectrum? And if so, can I, as a user, control whether I'm on Wi-Fi or LTE unlicensed since Wi-Fi is free? So I don't know. How do you see that the pricing working, Arun? I guess because you guys are the ones who have to count the bits.
So it's I guess a multi-part question, right? The first part of the question that you referred to is the device doesn't really know when to go back to LTE, it just chooses Wi-Fi as a priority because it's a less costly platform to deliver, but it doesn't have some of the reliability that you would see, and that's kind of that's why it goes back to the point I was making is that putting this decision that is self-learning in the network is really the right way to do it. And the network really knows, based on your need and based on your condition. Of course, it's a device assisted. It is not very different from a handoff, but the decision really resides in the network. Now coming back to your much harder question, which I think is not a technical question, it's a business question, right? It is a business question. I really, I think we're at a stage where we're still trying to figure out the technical issues and the technical complexities and the roadmap of, how we go, and utilize unlicensed band with LTE such as LAA or LTU. I'm not sure if there is a great really answer to answer that, but I think it's an important one because the question basically comes back is LTE when I'm on the unlicensed spectrum, do I still pay or not? And I think that's really what your question is. And you have to also remember is that payment or what a user pays is not just because of the license, it's also because of the infrastructure that you have behind it. So it's really not that easy an answer to provide, and I'm thinking that's really where I'm going to stop.
Yeah, good. Yeah, we want you to keep your job.
Jeff, can I add?
Yeah, sure.
There's just one part I think you asked also to the question about the user choice. Will the user be able to choose, to turn on Wi-Fi? Today, the user can choose, right?
Yes.
Select Wi-Fi versus cellular and so on. So absolutely, that capability will continue. So at the device level, the same way user selects Wi-Fi today, they'll continue to be able to select Wi-Fi. So LTE U or LAA essentially is going to be a carrier-managed decision to switch it on and off. And so in the same way the carriers today switch on and off your carrier aggregation capability, whether you have two LTE carriers or one LTE carrier.
That's what I figured. All right, one more quick question. I'm looking for a one-word answer from each of you. When will we see LTE-U in mainstream handsets like iPhone or Samsung Galaxy or some other? Nihar, do you have and if you don't have a guess, don't feel free. I mean, I know this is probably a question more for Qualcomm or maybe Broadcom. Like when will this technology be in the iPhone that that we buy?
That's more of a question for Cupertino, but I can talk about availability from Qualcomm's side. We'll have commercial chipsets available for LTU in the second half of next year. So both for small cells as well as device handsets.
Okay, so it'll be commercially available latter half of next year. Vinko?
And usually takes a year and a half to get it to production and into the phone, so probably 2017 then it will be based on what Eduardo just said.
Okay, so about 2 years.
No, we'll see it earlier. I don't think it takes
In
that
the
long to
phones.
become, yeah, I don't think it will take that long.
Okay, all right, good. Disagreement. Disagreement's good. So that's one of the guidelines I gave them. Is, yeah, we want disagreement, not agreement. All right, so let's turn to our audience for a questioner. Farouk.
Okay. So Wi-Fi and cellular are two very successful ecosystems. Billion of devices for Wi-Fi, billions for cellular. Right? And both are, and two independent ecosystems are very important for the consumers due to competition. And both are evolving with AX and AY. Wi-Fi continues to improve going into millimeter waves, and cellular as well. And the earlier question, I mean, should I pay for the unlicensed or licensed, is the backhaul. Like, Wi-Fi is not free because I'm paying for my broadband. Cellular, when I don't go on the broadband, I'm using the cellular backhaul in that sense. So I need to pay just once, even if I can do LTE in unlicensed in the home, if it's going on my broadband,
So is there a question?
it should be free. Yeah. The question is, these are two independent ecosystems. These are good for the consumers. In Korea, this Wi-Fi and LTE has already been deployed with carrier aggregation, multi-path TCP. So this thing can be done at the higher layers. You don't need to worry about at the radio technology levels. So why don't we let these two ecosystems evolve independently while the consumers can get the benefit by multi-path TCP and the aggregation and all that? Why we are even talking about all the coexistence and all these issues at the radio level? Is this something is needed?
So I guess the question is, why do we need coexistence? Vinko, you want to, or?
So Farouk, you raised a very good question, and actually we had Broadcom's proposal is to do exactly the same thing. Why to do something on the deep into the stack, deep into the hardware, or above the MAC level aggregation between the two technologies? There you can do it per IP flow aggregation, and I think that I think the carrier should be also carriers. I don't know, AT&T, maybe Arun can say for his company, but that would be, I think, appealing to them, to have a quick solution which gives 90% of all the advantages per IP flow aggregation, rather than having it deeply embedded into the in the modem between the Wi-Fi and the cellular. So that would be my preference, my company's preference to do so.
Is another dissenting or different take?
Well, I guess a green take that, yeah, we think the higher level aggregation, such as multipath TCP or other flavors of that are very powerful. You have two great PHYs. Like you said, it's good to have two for the ecosystem. That's not the only way to go, but that is a very powerful technique. It's already being used today. We would like to see more of that.
Yeah, I think, where we are, as I mentioned, we are interested in all different technologies. But usually when you're able to push the switching closer to the radio access, typically the agility of the system is much quicker. And, we have, seen, at least from a lot of simulations, that if you're able to coordinate and, bring the latency down between these 2 points that, essentially the LTE in the licensed and the unlicensed, or LTE in the licensed and the Wi-Fi in the unlicensed, if you can bring them the two of them closer, you really gain a lot more, system performance benefit. And I think from where system performance is really of the most important thing, because that determines, what the density of access points I have to deploy in order to support a certain amount of traffic. So that's really why I think it is in general a right direction that we are going, where we are trying to at least making an effort of these technologies to really coexist by integrating it at a single point.
Yeah, I mean, I think to go back to what Nihar was saying, and actually something that was in Google's white paper as well, is having a licensed carrier to fall back on sort of doesn't give the LTE devices. They have a different incentive. They have less incentive to behave nicely. And the way Wi-Fi works, for example, there's a lot of very subtle issues as far as rate control, That way acts are sent, and LTE, if it doesn't coexist properly, can just knock all that stuff out. And so the performance can go down much worse than you would think if there isn't some coexistence. And so I'm just curious, if anyone on the panel wanted to comment on that. I know that even our FCC chairman, when I've spoken to him, has serious reservations about the kind of this notion of these cellular operators having licensed spectrum and then kind of plotting sinners to, in a sinister fashion, in their licensed spectrum to then use this public unlicensed spectrum, and to yank it out of the poor common good, people that are just sitting there with their Wi-Fi devices. I'm curious if the panel would like to opine on that.
I have a comment on that. I actually think the incentives are in the other direction. Because if you have a licensed anchor, actually you have all the incentives to rely on it, because that's the fallback. You don't have any incentive to try to be aggressive on the unlicensed spectrum and take the risk that transmission is actually going to end up hurting you. So you have to think about, from an operator perspective, you're trying to manage the best utilization user experience. You have two spectrum available, right? You have licensed and unlicensed with different characteristics. You're going to, at any point in time, you're going to try to optimize and maximize the utilization of those resources that are available. And absolutely, having the license anchor is an incentive to not be aggressive on unlicensed. Actually, it's the other way. If you're, what we have seen, unfortunately, what we have seen, and we're working on both cellular and Wi-Fi. We're heavily vested in Wi-Fi, as you guys all know. What we have seen in reality, in practice, there are multiple implementations of Wi-Fi. Implementations actually tend to be very aggressive in terms of coexistence among themselves. Among Wi-Fi, we have seen tests where we have different implementations sharing the spectrum, and it turns out that we get some brands get access to the 90% of the median, and others only 10%. And I think that's the incentive. If you only have one license to work on, there is an incentive to actually be aggressive.
Nihar?
Just to follow up, I think having using a licensed or unlicensed spectrum on an as-needed basis is a good feature, but having that fallback also means that if you're carrying, you can use the unlicensed spectrum opportunistically. That changes. You don't need to use it for all your users. Is one very simple observation. Whereas a Wi-Fi system that must serve all its users on unlicensed spectrum needs a robust system that works even in corner cases. It may not work perfectly. I agree. That's definitely true. But an LTE unlicensed system that is happy to serve 50% of its users on unlicensed, the other 50% exclusively unlicensed, doesn't have the same robustness requirements. That can really change designs. You can have a hole in the unlicensed spectrum from a LTE perspective because those users can be served on unlicensed. And that can't be said of Wi-Fi, for example.
Good, disagreement. Great. Vinko.
So Eduardo is right. So it's only actually just one device was found that takes a lot of the resources, medium access. And I think that this device should be investigated because it does not comply with the IEEE specification or Wi-Fi line specification. So I think it's an outlier, and in general, all the other 4 or 5 devices which are tested, they had very similar performance, which was expected performance.
No, actually, we saw more than one. We have combinations of devices that don't hit the spec.
Oh, no. We tested also quite a bit of them. We found one, and Wi-Fi lines found one, too.
Keep searching.
Maybe it's the same manufacturer, multiple devices.
All right, great. Question, Amitabha.
Yeah, so this is a speculative question. So the question is, who will win, the traditional operators or the non-traditional players?
Who and when of LTE unlicensed?
Yeah, the non-traditional players are getting into the cellular business, right?
Yeah, so it's basically a who will win kind of question?
Is it a win-win situation?
You must know something I don't know.
Any of the panelists like to respond to that? Vinko?
Maybe I can say in generally how I see it. This is my opinion. LTE LA will provide to smaller players which have maybe access to just a little portion of the spectrum. Now maybe they need 5 megahertz or 10 megahertz, which they can carry voice or maybe a little bit of video as a high QoS applications. And all the other traffic they put on the unlicensed carriers. So they will give an entry and competition to carriers. If future, I believe.
Yeah, Luke.
Questions regarding running VoIP calls on Wi-Fi and the impact of LTE on that. I mean, at one extreme, you can kind of do nothing except just immediately turn on the LTE. You obviously have lost packets during that transition. If you inject weight, maybe you can avoid the loss of the packets. I'm just wondering about the trade-off there between either latency or packet loss ratio, kind of optimizing that from a application standpoint for the VoIP Wi-Fi call.
Yeah, very good question. So we found that in Wi-Fi, 40 to 50 milliseconds is about tolerable to do that. And now there are different, so I'm mainly concerned by LTU. So there are good implementations of the LTU. I have to admit that Qualcomm showed there was a workshop that they showed quite advanced coexistence mechanism, which I still have quite a bit of questions there. I would like to see it work in my lab and then figure out how it really works. But the other implementations, they are not good, actually. There were some presented there, and they have very crude energy detect, again, at minus 60 dBm. So they don't see 30 dB of the Wi-Fi below 60 dBm, minus 60 dBm to minus 90 dBm. So they will set up a duty cycle based on the observation that does not see 80% of the Wi-Fi traffic. So, and they can set up the duty cycle up to 95%. So I'm really scared about these implementations that which do not detect Wi-Fi signals at very, very low levels. And this will be devastating for voice over IP and video traffic. And Qualcomm's solution, I mean, Eduardo can talk more, but I'm going to say a little bit about their solution. It's better. It uses, yeah. I don't know if it's good enough, but again, I want to see it in my lab. So it uses a sniffer, Wi-Fi sniffer. That means that they do detect the signals at minus 90, maybe not minus 95 dBm. And then based on that, Qualcomm determines the duty cycle on and off period, which is allocated. Off period is, of course, allocated to the Wi-Fi. I still have questions how well this works in very changing traffic, dynamic traffic, when you have IP on and off. And when a duty cycle is sent, how long does it take for the waveform duty cycle to change from 90% to 10% or 5%? I mean, depending on the frequency and how on and off Wi-Fi traffic goes with high QoS applications, just like voice and voice over IP.
Okay. Gerhard.
So I would like to take, let's say, different role than an operator's view. From an operator point of view, the handset has to be as cheap as possible. Now, LTE unlicensed will be part of the cellular chip, not of the Wi-Fi chip, so it will make the cellular chip more expensive. The second question is, obviously then, if that happens, it will also, on the operator side, require to install LTE hardware equipment. Who's going to install that? So who's going to pay for that? Why would I? Because if I take today's traffic, and we do measurements with our traffic monitor, with one of our startups, and we can find out that in 150 countries on the planet, more than 90% of the data traffic is Wi-Fi offloaded anyhow today with smartphones. So where is the problem that is going to be solved with LTE? Phones more expensive, and the offloading is happening anyway.
I think we can count this as a skeptical question. So who's going to put this in the phones, and who's going to put this in the network?
I can give it a try. Maybe everyone can comment too. Well, multiple questions in one there. So let me try to address the cost first. And so because it's LTU is going to essentially leverage LTE and LTE carrier aggregation mechanisms. So the additional, the incremental cost to an LTE phone is negligible. So essentially, what you need to do is support the band, support the 5 gigahertz band, which wasn't supported before. Well, what's more expensive, I don't know. just an additional band like we already support lots of LTE bands, just one more. On the infrastructure side, you're right. So the operators will have to deploy small cells also with the 5 gigahertz capability. And as operators begin to roll out more and more small cells, so that it's not just that has a small cell, there will be more people and venues that will have small cells, and we're beginning to see that happening very quickly. Then they have the option of rolling out LTU or LAA support. From an operator point of view and a user perspective, it's going to be an increase in performance. User experience.
I'm offloading anyway, so where does the increase in performance?
A performance increase in terms of a seamless user experience, better throughput range that you would have with the switching, with the existing switching that exists today, which is, either you are on cellular or Wi-Fi. So by far, the user experience is well understood that it's going to be better, and that's the main motivation for the operators that are considering LTU or LAA.
Arun, would you like to add in?
Yeah. I think I'll defer to Eduardo for the cost because I'm not really an implementation. But I can address the question as to why we would like to have the switching much more dynamic and in the network. I mean, it's the same principle as dynamic link adaptation. Why do you link adapt your transmissions to short-term behavior of the channel rather than just do a long-term selection? It's precisely because you want to adapt to the dynamic changes of what's happening. And that's really, and the only way to really do that is not do a static bifurcation of traffic between the device and let that happen, but rather it be able in the network to have this dynamic control to be able to switch. And pretty much all simulations, a lot of tests, do back that up. So that's one motivation for sharing, putting the control on the network. Another reason is that, I may have multiple. That's a good ring to. Yeah, that's a great example. So I may have a multiple streams, and don't think of a device as a single device.
Amitabh, get it together there.
It must be a very important call, which is why you cannot switch it off. The control is not in the device. But, yes. So I may have multiple streams streaming to an end device, and some of them might require high quality of service. Some of them, I think might have lost the point. Thanks, Amitabh. But anyway, next question. Thanks.
All right. So we're almost to lunchtime, even though we started a little late. So I'm going to ask for a little grace time from my moderator. But so I'd like to, this is we're focused on 5G. I think this is a really important problem for pre-5G to solve, and I think solving it and getting it working right is can be very very critical and interesting step. But let's maybe spend the last 5 minutes talking about 5G. So let's as Vinko mentioned, 11AD is now standardized. Devices are coming out. This is a millimeter wave Wi-Fi technology. We have 7 gigahertz of unlicensed spectrum up there around 60 gigahertz. I mean, 7 gigahertz. I mean, this is like more than everything up to this 5 gigahertz combined, right? And so if we could harness this and get this working for Wi-Fi, this is an obvious next thing that could happen. We could talk about, unlicensed operation by the cellular operators in this spectrum as well, which introduce some of the same possibly coexistence issues in that spectrum. If AD becomes successful. So I'd like to ask the panel what they think. What will be different, or similar? Or, when do you think this is a next step that we'll start looking at perhaps the 60 gigahertz spectrum or other millimeter wave spectrum, and what can be ported over from what we're learning here and doing here, and what will have to be totally redone and new? Nihar, you have a...
So a general comment about that, yeah, I think it's very important. It's going to only increase in importance as you're going to see cellular and unlicensed, cellular and Wi-Fi-like technologies in 60 gig. I think important thing is that we start early, standards bodies get involved in the process early. In this case, I think LTE was a late entrant to 5 gigahertz. Inevitably, the two technologies were already mature and had to develop afterwards. It was an afterthought. We know now already that this is going to be there at 60 gigahertz, so start the process now. I assume 3GPP will, I mean, I've seen designs for 5G that are already thinking ahead to how do we make frame structures that work well in licensed spectrum. I think we can talk about interoperability, going beyond energy detection. I know Broadcom's brought this up too, is we shouldn't just think of simple things like energy detection, we can do more. Preambles that are decodable by both technologies and things like that. So forward-looking work like that by standards bodies.
Well, do we even need it at millimeter wave? Because millimeter wave only works if you have directionality. You need to have high gain antennas, and so this kind of might this eliminate some of the interference issues? Might it be actually easier at?
I mean, it'll change it. I mean, Arun brought it up for sure. The high directionality will change it, but.
Yeah.
Arun brought a good point. It's a link adaptation. So basically, you go from 60 gigahertz to 5 gigahertz to 2.4 gigahertz to 3.5 to 900 or 600. It's available. So how I see it is just one link adaptation. And high frequency are going to become more and more important in 5G because there's a lot of proposals on that, and we're talking about massive this and that and everything massive. And to have it massive, you need a lot of bandwidth, and you need small antennas with a lot of antennas. And I think that's above 14 gigahertz, 24 gigahertz, up to 60, 70, 80, 100. There were presentations on 300 gigabit solutions right now also. So we're heading that way.
Anyone else have any comments on how this might shape up and, even beyond this, the next phase beyond 5 gigahertz?
Yeah, absolutely. I think what's happening with all the LTU and LA discussions is going to be, it's good being a good learning experience and having the industry discuss the opportunity of basically using a licensed spectrum in new ways. Coexistence discussion is also helping us better understand also what's happening in the licensed spectrum with Wi-Fi. I think there's as we look for evolution, I mentioned multifier, which would be a next natural step on the LTU front, which basically would bring in an opportunity to develop a self-contained LTE-based mechanisms for unlicensed spectrum that has both uplink and downlink and no dependency on the license carrier, and that will open up opportunities for different players to actually start leveraging LTE-based technologies. And then going forward with 5G evolution and also with Wi-Fi evolution, what we expect is also Wi-Fi technology will actually learn from a lot of these coexistence discussions and will improve because, being discussing here about energy detection and thresholds at minus 62 dBm, it turns out that Wi-Fi is not very friendly to known Wi-Fi technologies because the threshold that Wi-Fi uses is minus 62 for other known Wi-Fi technologies. So I think we have to, as we evolve 5G standards as well as Wi-Fi standards, we need to kind of taking those things in consideration and design better systems.
Yeah, let me ask you one last question. You can answer both. This is the last question I asked the panel. Let's just say, for the sake of argument, we work all this out. And, by 2018, 2019, it works great. Gerhard's skepticism is overcome. And, we have, widespread infrastructure deployed doing this technology. And we have, Wi-Fi still works, the sky doesn't fall. And everything works better. Let's just say the best case scenario happens. What would this mean for the FCC? Does it mean that as it releases millimeter wave spectrum, other than the 60 gigahertz spectrum, which we know has some issues going far because it's an oxygen absorption band, should they just make all future broadband spectrum unlicensed? I mean, if Wi-Fi and cellular can coexist in coexistence mechanisms, why not then, ask the carriers to coexist? Why not just, make everything just sort of a unlicensed, with some rules, but not actually have exclusive license, other than the obvious answer that then there's less money in the coming into the treasury directly.
Amitav, are you expecting a call? No? Okay. All right, then I'll start. No, I think, I don't think, there is any belief that all spectrum should be unlicensed. I don't think that really works because as an operator, you have to deliver things with a certain grade of services. In fact, with 5G, one of the key requirements is to be able to even start supporting, much more mission-critical services, as that relates to accidents avoidance, public safety, and things like that. So a lot of those assurances are out of the window if you have everything unlicensed. So that's really why I believe, the combination of the licensed carrier and the ability to, opportunistically use unlicensed carrier, is really the best way to go. So that's kind of, my view on
So
that.
it's important to have you think it's important to have the fallback. So
Yes,
so in a way, you're deeply skeptical about them coexisting well, because you kind of implicit in your answers, there has to be a fallback to a safe spectrum where you sort of know you own the turf.
Right.
Just one point. I mean, I mentioned a balanced approach to licensed and unlicensed before, but specifically to millimeter wave, the licensed paradigm is already quite different in around 70 gigahertz, for example. I mean, it's lightly licensed. I don't know if that's what the FCC actually uses, but you can buy for a very low amount of money a license for a point-to-point operation in millimeter wave, for example. So how we think of licensed spectrum may be different in millimeter wave than
Maybe something in between licensed and unlicensed.
or licensed, but yeah.
Like, where, multiple people could buy licenses, for example, or.
Right.
Per location, basically, you buy it. That's another school of thought.
Well, we already have per location licenses, but you could actually imagine, two operators sharing the license, and
With
having some coexistence protocol.
Yeah, or with high directionality alone.
Yeah,
which is basically
because of the
how
high
it works today.
directionality. All right.
To some extent, those principles are already being discussed even in the context of 3.5 to some extent. So going back to the point that Arun mentioned on the license spectrum benefits and the investment that the operators have to make to provide the reliability and the quality of service, I think that's a critical component. That's why licensed spectrum is going to continue to be needed, because it's the only way the operator will know for sure that the capital investments they make on the network will have the return they need to expect and show to their shareholders. So, and that's why you have those figures, why spectrum is so expensive, because it's part of the whole business plan and how, to try to justify billions of dollars of investments on the network side.
Okay, I think, we're already 10 minutes in, so I think we're going to conclude the panel and take further discussion offline, but let's take a panel for a very lively discussion. So as far as lunch, actually, I'm not sure if it's set up upstairs or downstairs, but there'll be a boxed lunch, and you can eat outside. There should be tables outside as well.
Yeah, I do, yeah.
And then we'll come back here and start at 1:20, so maybe a few minutes after that. So about 45 minutes for lunch.
Good. That's good.